Hi everybody, my name's Tel and this is Tel's Bench, and today we'll be running a small course in this video to run over the main elements of the BBC Basic as it relates to the AGON Light, which is a relatively new single board, super fast 8-bit computer. So BASIC, which stands for Beginner's All-Purpose Symbolic Instruction Code, originally invented in the 1960s. In the early 1980s, Acorn Computers in Cambridge won a contract to design a microcomputer for use in schools so that all children would have an equal opportunity to learn about computers and programming. This was called the BBC Micro and needed a programming language, so a version of BASIC was chosen for this and created BBC Basic. This was ported and rewritten for the AGON Light along with altered and new functionality. There is a lot to cover, so we will not be fully covering the assembler part of it, as this requires a specific skill set and will be done in a different module at a later date. Games and other programs written for the Acorn BBC Micro in assembler will not work on the AGON Light, and this is because the AGON Light uses an EZ80 processor and the Acorn BBC Micro was fitted with a 6502 processor, which would not be compatible. So we're in the basics section now. These are just some of the fundamentals that you will need in order to create any code in BBC Basic. We've already loaded and run Basic, and you can see the prompt there. The first thing I'm going to do is to enter some basic code, but in Basic you will always use a line number as a prefix for each line that you write. So we'll put in 10, and in uppercase you put the keyword, in this case print. I'll say hello 10, and I'm going to put line 20, print hello 20. So we've got a program. Maybe I want to change the line numbers. Maybe I've had to put some line numbers in the middle, like on 15, so let's go and do that. So at line 15 I'm going to put print hello 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 hello. Okay, I've got that now. So if I CLS, clear the screen, and then list, I've got that. But that's kind of not what I want to do, because I want all my lines to have a 20 gap between them, so if I need to put more lines in I can do that, as you just saw. So I now want to renumber that so it's all back to normal. So if I put in renumber, and then I can say I want to go from 10 onwards to 20. And now if I list, look at that, I've got 10, 30 and 50. But let's go back and change it back, because I feel a bit extravagant today. So 10 onwards, and then we'll actually put it back to 10. Let's see if it's done that. And there it has, it's put it back. So I've said from 10 onwards. I didn't specify 10 to 50, I just said from 10 onwards. You can put anything from 1 to 65,535 in for a line number. That is your range. You can't put in 0 because it won't accept it. In fact, if we put in 0, print 0, it prints it, but when we list it, it's not there. It just ignores it. So it will ignore number 0 and just treat it as if you typed it in at the prompt without a number. If you put in 70,000, 70, 123, which is above our range, and I say print 70, it will say it's too big. Actually, I'll teach you another new command. It's a little bit early, but if I want to clear everything I've done, all I have to do is type in new. And now if I list, I've got nothing there. There you go. That's how to enter lines in. The other thing that I haven't told you is if I put in hello, what do you think will happen? It tells me it's a mistake because it needs all keywords to be in uppercase. No lowercase keywords. Those are reserved. Those keywords like print and new and CLS and any other keyword that you can think of. And you can put things like CLS in your program, so you could put it at the beginning. So we've got nothing in there at the moment. A common thing to want to do is to say 10, CLS, and then you can go 20 print some text. Now if I run the program, it says some text because it's cleared the screen first, and I'll run it again and it'll do it again. So that's a useful thing to do, to know how to clear the screen, to know what to do in terms of the case for putting in a keyword, and how to renumber things. So that's quite a lot of information in that small demonstration that I've just done. So we got some stuff in there. So what if I want to change 20 to read some good text? Well, there's something called a line editor, which I can type in, and because that's a star, that means it's an MOS command. And MOS stands for Machine Operating System. So this is a command, one of many commands that you can use to do things on the system. You're going to invoke an MOS command. I don't think it needs to be in uppercase because that's not basic. So it's edit line 20. And now we're actually in the line editor for that. So you can use your cursor keys and so forth and back delete to change things. So I can cursor to there and then I can just enter that. And now when I run it, which has to be in uppercase, some good text. So far in just a few minutes you've learnt the ranges for the line numbers, you learnt how to use the print command, you've learnt how to renumber them, and you've learnt what happens if you go outside the range. Okay, you've learnt what a keyword is, the fact that it has to be uppercase. You've learnt how to write a very basic program using the print command and the CLS command for clearing the screen. You've learnt the line editor facility, edit a line using the cursor keys, and how to enter corrections. So that's some of the basics that I wanted to give you. Enter will always enter a value, and escape will leave it unchanged. So if I just go back into that again and I say start edit 20, and I do my backspace there to delete those, or back delete, and I put in really bad text, and instead of hitting enter I just escape. Okay, it says escape and it hasn't changed it. So that's the basics done. So this small section, this basic section, is just to really get you off the starting blocks, and you'll be seeing many more of these keywords as we go through the material. Okay, so this is the order of operations section. Order operations is basically if you do a number of actions on one statement in BASIC, it's the order in which it evaluates those expressions. This in itself is a big subject because it covers quite a lot of things, and I'm going to try and make it as simplified as possible for you so that you don't get overwhelmed with it. So in the order of operations, the first thing I want to look at is something called PEMDAS. Does anyone remember PEMDAS? I'm sure if you come from America you definitely do. If you were educated in the UK you might have been taught BODMAS possibly, or if you're a newer student these days maybe PEMDAS, who knows. Both of them mean the same thing, and they are an acronym which refers to the order operations in a mathematical sense. So if we've got a handful of numbers, 3 plus 2 divided by 7 multiplied by power of 2, etc., etc., this will help you work out how, if you wrote them out, it would be calculated. And in fact, all computers, if they're worth their salt, will actually evaluate them in that order, because that is the correct mathematical way to do it. So we'll use the American acronym because I think it's better, it resonates with me better, and there's actually a little rhyme which helps you to remember it, and it's please excuse my dear Aunt Sally. I have no idea what Aunt Sally did, but it's been useful. But that is the little rhyme, jingle, whatever you want to call it, will help you cement that in your head if you don't know it. If you do know it, that's fine. But for those who don't, it's an important concept in the overall scheme of order operations for the AGON LIGHT BBC Basic, because it's a major part of it. There are other things that go into this mix, but we'll cope with those later. I just want to fixate on this one first to get that out of the way, and then we can move on. And the reason that we want to do this is because it will help you understand what you can actually write in and how it will be interpreted by the computer. But it's good to understand it anyway as a basic concept, and then the other things will fit in around that. PEMDAS stands for the order in which they're evaluated from top to bottom there, or if you wrote that out from left to right, it would be from left to right. So parenthesis, anything in parenthesis will be the first thing to be calculated. So in your line of calculation, from left to right, if you've got a parenthesis, you have to go and calculate what's in that first. Then you apply exponents. So wherever those exponents, powers or roots that you find, you'll apply that to that item, calculation inside a bracket or parenthesis, if you want to use that word, and you apply those from left to right where you find them. Multiplication and division a pair, like a dynamic duo, as are addition and subtraction. So multiplication and division, you go from the left hand side of the expression to the right, and you'll say, if I find a multiplication or a division along the left hand side to the right hand side, as I find them, I will do that calculation. And then you do the same thing with addition and subtraction. So there's kind of 4 operations done in 2 stages with all of these different things in. So what I did was I prepared a PEMDAS questions to illustrate how this works. So if I do chain, you haven't seen that command yet. That means basically run something that you load, which is a basic file. So chain, I can write it out chain, or I can write it out with a ch dot. So it's going to be PEMDAS questions. And that gives you 3 examples. Please excuse my dear Aunt Sally with the PEMDAS acronym before it. So let's have a look at the first one here. So we don't have any parentheses here. So that's the first thing we look for. We don't have any powers there, or exponents, I should say. But what we do have is a multiplication and a division there. So those things that we need to do. Right, so if we go left to right, we leave that because that's an addition. There, leave that at the moment. We'll apply this rule and calculate this because it's a multiplication. So that's 35 times 2, and that's 70. And then we've also got division, which is in the first dynamic duo there. I will say 70 divided by 10 equals, yes, 7. Yes, right. And then we'll go back to the beginning and run through again. So we've got 10 plus 7 equals 17. So what I'll do for the next 2 is I'll actually let you think about it. I won't tell you what the answer is, and I'll give you a few moments and you can think what the answer is. So here we've got 10 minus 5, so we're not going to be doing that. 35 times 2, so that's 70 divided by 10, and you know that's 7. So what's the answer going to be there? It's going to be 12, isn't it? Because we've got this 70 divided by 10, and then we go back to the beginning. We go 10 minus 5, which is 5, plus 7 equals 12. And then the last one, we've actually got an exponent and a parenthesis in there. So a parenthesis first, so 3 times 2, which is 6. Raise it to the power of 2, which is 36. And then we go back to the beginning, and we say multiplication. 5 times 36 is 180. Divided by 10 equals 18. So that's what I think it is. So if I load up the PEMDAS, I said that with an English accent. Now let me load the answers. So you see, remember this one, it was 70 divided by 10 plus 10. That is the way we do it. We don't just start at the beginning of the line and go through it. We use this rule to find out what we need to evaluate first. So I hope you found this PEMDAS little refresher useful and interesting. But now we're going to go on and look at the other operators that need to be included in the order of operations. It won't take too long, and we can then get on with other things. Okay, so in the last bit we did PEMDAS, and over here I've got a legend, and I've also got order in expressions, which covers the stuff we did in PEMDAS. So we covered the parenthesis, which is this one here. We covered the exponent. We covered times and divide, and we covered plus and minus and how they work together. So what I'm going to do now is I'm going to talk about some of the other ones. So I'm going to talk about the mod and div. Those are the two that I'm going to look at now. What I did was I wrote a small program to give us some examples. I'll list that now so you can see what you're going to see. So we're going to be doing multiply, divide, which is multiplication, divide, mod and div, and how they relate to each other in terms of priority, what gets evaluated first. So we've got 7 examples here, and for each one of those we print out this, which is just telling you what we're doing, which is the sum, or the expression if you like. And then we actually print out the answer because I type this in again there, and then we tell you what priority what is over what, and that's done 7 times. So I'm just going to run this. I will go through them one at a time. So we know that the multiplication and divider have got a higher priority than the mod and the div, and the mod has got a higher priority over the div. So let's have a look at the examples we did. So here in example 1 we've got 5 times 6, div, and then mod. Well, do you know what a div is? Let me tell you. A div is a divider which gives you the amount of times a quotient or an integer on either side of it goes into the left hand side. If it was just 6 divided by 4, this would be 1, because there would be one time that you could divide 4 into it. The mod is the kind of the opposite, because it gives you the remainder. So 4 into 6 would go 1, and you'd have 2 left over. So let's look at these sums then. So for 1, we know this beats that. So this is going to be 30, 5 times 6. So it's 30 div 4, which means we can divide 4 into the left hand side 7 times. And it means that is prioritized over this. And then we do the same for mod, go with the same divider, and we find we get a 2, because that's the difference between 28, which is those two divided by 4, and then the remainder is 2. And so that also applies there, but it's a mod this time, not a div. And in this one, which is 3, again, these are prioritized over the div. So we have 10 divided by 2, which is 5, divided by 2, which means that can go in there twice. 2 2s are 4. Okay, and again, divide over div. And this one is the mod. 5 goes into 10 twice, so that's going to be 2. And if I divide 2 into 2 with a mod, I'm going to have no remainder. So again, that's the priority. For the 5th one, we've got a mod and a div. 20 mod 11, 9 remaining. We divide that by 3, and that can go in there 3 times. So that works, and it means mod over div. On this one, 6, we've got div gets evaluated first. That's got a higher priority than plus and the minus. Div is executed first, so div 5, div 3 means that they're going once. So that's 1. 10 plus 1 is 11. Priority div or mod over the plus sign. And this one, number 7, is the same thing. So in number 7, again, div takes priority, so we'll go 5 div 3, and that's going to be 1, because it'll only go into 5 once, and then we take 1 away from 20, so that gives us 19, and again it's priority div over subtract. For the other ones in here, so you've got functions, variables, these two, they are indirection operators, and this is just a binary add or subtract, and you've got a not. Those are the ones that we haven't covered. And also the 3 and or, EOR, exclusive OR, and OR, which are binary and logical operators. So those and EOR and OR sound like a donkey. EOR. What I suggest that you do, if you're interested, is to actually go and experiment with these. And look at the literature. I've got this line here. It says, for the few remaining, suggest you experiment and refer to the manual linked in the comments section. So there is a document written by about 5 people really over time as it's evolved into the AGON Light version of BBC Basic. It's crammed with stuff. It's far too much. It wouldn't be far too much to include all that stuff in this video because it would be so long you'd fall asleep or become bored with it. I'm just taking the main parts that are useful, but we'll run through the whole thing and I'll go into some of them in a bit more detail, and some of them I'll just tell you to go and either look it up or look at it if it's of interest to you, because for example, when we come to look at the trigonometry section, things like sine, cosine and so forth, but really there's no point in going and doing that stuff because for some people they'll have forgotten all about that and they won't even remember what a sine or a cosine is. This is not about teaching anybody to learn those mathematical practices, but it's just about telling you where they are and what they do. Okay, those kinds of things I probably won't be covering in this video. So that's the kind of approach I'm taking to it. If there's a particular requirement comes out, oh yeah, please do this, then I'll do that in a separate video. But I thought covering the order operations PEMDAS was an important thing to cover and to get out of the way first of all. So with that out of the okay, so let's touch on variables, then we'll have a look at the assign and compare operations. So with variables, the naming for variables has got to start with a letter. So we can have letters and we can have numbers in the variable name. If you take a look here, we have real numbers. Okay, so that is just an example. It could be A, it could be B, C, whatever. And they're stored in 5 bytes for real numbers. I put there mathematically not real because, as far as I know, a real number should be infinite potentially. Right, so this is not truly real. Some maths genius is probably going to call me out and tell me I'm wrong, but I believe I'm basically right, although I might not have phrased it correctly. So integers, they have a suffix of a percent mark there, and they're stored in 4 bytes. So these are whole numbers and they're also static. So there is no Boolean assignment. You can't assign a variable to be Boolean, but you can test the value that variable has. So for testing Booleans, if it's 0, it's going to be false. If it's -1, it's true. But if it's minus anything, it can be true actually. So that's where we are with that. We come on to strings. So strings are suffixed with a dollar mark. Strings are allocated up to 255 bytes. So that's done dynamically. If you type in a dollar equals in quotes 1, 2, 3, 4, 5, you'll get 5 bytes. If you allocate it at 255 bytes, you'll get 255 bytes. So if you allocate a dollar, for example, to be in quotes something that's 50 bytes long, and then you decide, oh, actually I want to make a dollar equal something that's 100 bytes long. What happens is it will allocate that 100 bytes somewhere in memory and then point a dollar to that, and where a dollar originally pointed to will no longer be referenced, so it doesn't automatically release that memory. So if this thing may happen and you don't want it to happen, then you should do one of two things. You should either allocate the maximum so you can change it, or find some other way of managing memory and maybe using dereferences. So for assign and compare operations, I thought I'd just put a few things in there about that, talk about it a little bit. These dots are not decimal points, they're just bullet points, so just ignore the dots really. You'll probably know this if you've done any programming anyway, so if you have and you understand this, to just skip to the next section. But for those who might be coming in fresh, if you like, the equal sign can be either, this is one thing I don't like about BASIC actually, the equal sign is used either as an assignment or an equality. And what that means is if I test a value, so I conditionally want to do something, like with an if statement, if A equals B, that means I'm testing the equality, and based on whether it's a true or false, then I can do something or do something else. And these really speak for themselves. So if you're doing a test, these are all tests. So saying if the left hand side is greater or equal to the right hand side of this operator, then act appropriately, and it just goes down there, not equal, less than or greater than. That's it really. I just wanted to touch on those because it's part of it and because we need to just understand how these things work. So on the assign and compare ops, what I did was I wrote a little program, a little noddy program, so I'll just list it for you to see what it does. So it really goes down these assignment equality operators here. The first one it covers really is just that. It just says for one assignment, this is an assignment. And it does a similar thing for equality and all the other ones. So let's just run that and see what it shows up. Oh yeah, and then what it does is it actually, after printing that, it then goes and does the calculation. It's if 3 equals 3, then print equal, etc. So you'll see if I just run it now. So we already did assignment and we did equality. So if 3 equals 3, then print equal. Otherwise, print unequal. And it was equal, obviously. 3 is greater than or equal to 2. Then print greater or equal. And that's what it did. If it's less, then it's smaller or equal. If it's not equal, print not equal. And it was not equal. If it was smaller than, then it's going to be smaller. And we say it's 2 is smaller than 3. And is larger, 3 is larger than 2. So that's it really, it's quite simple. And once you start using these operators, you'll find they come second nature, they're just common sense to you. I'd like to just recap what you've learnt, what you've seen. We did an overview of the history and where we are now with AGON LIGHT and BBC from its beginnings. And basic as a basic concept, where that came from, or when that came from rather. And we did some fundamental things like line numbers, you did print commands, various other little commands that you learned, renumbering and numbers, the line number range, if you remember back to that, what keywords are and how they have to be uppercase. We did a little basic program, a couple of them I think actually, and a line edit, how we could edit a line using the start edit and then the line number. We did the order of operations, the basic flow of priority for various operators, in particular PEMDAS, which is please excuse my dear Aunt Sally. We spoke about that. And then we did some other order of operations, some other symbols, how they work. And then we did variables and equality. There's a tremendous amount of information to consume in BBC Basic. Actually, once you get into it, it seems fairly straightforward, and which it is, but there is a lot of variance in it, a lot of ancillary things to know about different commands and how they work and stuff like that, and tips and tricks along the way. So in doing this video, I used various sources of information. I used my own knowledge right in BBC Basic in its previous form over the years, and examples and things, a whole bunch of stuff. You should refer to the manual. It's linked in the description of the video section, and that gives a lot of in-depth stuff. But this video is meant to be a higher level than that, for people who are just sort of beginning to learn how to program basically, or maybe they've never programmed BBC Basic on this platform, and it's to show them visually and verbally how things work rather than having to plow through a manual. I don't know if this is going to work, but this is what I've decided to do, is episode 1 if you like, and we'll see what the reception is. If the reception is positive and a lot of people want to see more and go in more depth and stuff like that, we'll do that. Do like and subscribe because it helps me build the channel. So I'll leave it with you to think about, and you can let me know what you want. And until then, I will see you next time. It's gonna be